Okay, so on to cofactor expansion, which is not that difficult. It's kind of long and annoying, but it's not difficult. So let's have a look at it here. So suppose I have a matrix. We're going to choose a matrix here, which is called B, and B has the form 5, 2, 1, 0, 6, 3, and 8, 4, 7. Okay. That's the matrix is that the matrix we were working with before? Well, it doesn't matter. Okay. So this is my matrix. Okay. And we said before with determinants we expanded out in a row or a column. Okay. And what a cofactor is suppose I find a particular element of B. Okay. So consider we'll call it BMN, which is the entry in the mth row and nth column. Okay, so for example, okay, B11, 1, 1 is what? First row, first column, that's 5. Okay, so what I need to do now is I want to find the cofactor of this. Okay, well, the cofactor of BMN is the sign corrected determinant of the matrix formed when, and what do? Exactly the same as before. I delete the mth row and nth column. And these are deleted. Okay, so let's consider that B11 again. Okay, we had the entry 5. Well, what is the I've missed a multiple of the determinant, I should say. Okay, right. So what's the? So I want to find the the minor the cofactor here. Okay, what is the cofactor? Okay. Well, the cofactor is like I said, it's a reasonably straightforward thing. Okay. I need to look at this 5 here. Okay. It's my first row, first column. I'm going to delete my first row and my first column, and we see that I have a matrix here, which is, I want the determinant of 6, 3, 4, and 7, which is what? That's 6 times 7 minus 4 times 3. Where is he getting these numbers? Am I making a mistake? Oh, no, he's choosing a different number from me. That's fine. Okay. So 6 times 7 minus 3 times 4. Okay. Which is 30. Okay. And now I have to sign correct. Okay, according to my sign matrix. Okay. Sign matrix is something we discussed earlier. I have that here. That was done in the last lecture. Plus, minus, plus in the first row. Minus, plus, minus in the second. And plus, minus, plus in the third. Okay. And since this came from the first position, it goes to plus times 30, which is plus 30. Okay, so that is the cofactor of 5. Okay. This is the cofactor. Okay. Okay, sorry, I had to pause there for a second. So we'll continue with this cofactor stuff. Okay, let's choose another entry here. Let's choose the entry in the first row, second column. So that would be B1, 2. And what's that? That's 2. Okay. That gives me a 2 by 2 matrix when I delete the second row, first row and second column, which is 0, 3, 8, 7. Okay, which is what? That's 0 times 7 minus 3 times 8, which is what? That's minus 24. Okay, so that's minus 24. Okay. But now what I have to do, okay, is I need to sign correct, okay, according to the sign matrix, okay. This is in the first row, second column, and we can see that by our sign matrix form that we had earlier, first row, second column gets a minus sign, okay. So now we sign correct, and I have, I sign correct, and now I get minus times minus 24, which is plus 24. And that's the cofactor. Okay, so relatively simple, straightforward numbers to find, okay? And now, okay, here's the really tedious part. If I want to find an inverse, I need to use something called Cofactor Expansion, which means I need to find the cofactor for everything. Okay, so we're going to let A, and we're going to do only 3 by 3, okay, we have A11, A12, A13, A21, A22, and A23, and then we have A31, A32, and A33. Okay, so we're going to let a number called A1 sub 1 be the cofactor. It's the cofactor of the A11 here. Okay, then we have a cofactor matrix. The cofactor matrix is is written like this. Okay, the cofactor matrix is written as C, usually with a little bar here, just on the tail here. Okay, and that's just the matrix of corresponding cofactors. So A11, capital A11, capital A12, capital A13, indicating cofactors. A21, A22, A23, and finally A31, A32, and A33. Now, unfortunately, that is not the inverse matrix, okay? It's the cofactor matrix, which is important, but it is not the inverse matrix, okay? To find the inverse matrix, we need something called the adjoint, which is not the inverse either, okay? The transpose of the cofactor matrix is the adjoint. Okay, so here I have cofactors. Well, how do I get the adjoint? Well, that's the transpose, okay, which is referred to as adjoint of A, like that. And I interchange the rows and the columns, okay. So instead of A11, A12, and A13 going across the first row, now they go A11, A12, and A13 going down the first column. Then I would have A21, A22, and A23. Okay, changing the rows and the columns. Okay, and then I would have A31 over here. I would have A32, and finally A33. So that's the adjoint matrix, and the adjoint matrix is not the inverse either. Then, okay, here it is. Okay, if the determinant of A is not equal to 0, then, okay, here it is. Okay, the inverse of A is equal to 1 over the determinant of A, which we now know how to find for a 3 by 3 matrix. 1 over the determinant, and we multiply that by the adjoint matrix of A. Okay, so we have the adjoint matrix divided by the determinant. That is the inverse. Okay, that is my formula. That's really annoying, but it is what it is. So we're going to do an example of how to find this probably in the next video, but for the remainder I just want to show you how this works in 2 by 2 because it's a bit simpler, and that will help you to see how things work. Let's take an example. Let's take a fairly simple matrix. Let's let an matrix A here be equal to, you know what, let's make it completely, totally general. We have A, B, C, and D. Okay, so this is my matrix A here. These are my entries, A, B, C, and D. Well, what's the determinant? Well, we worked that out before. Well, let's work out all of the cofactors, okay? So let's look at A here. What's my cofactor when I have that, okay? Well then, it's the determinant of the matrix that's left when I delete the first row and first column. So that's just D, okay? The determinant of D, which is equal to D. And remember that we have the sign matrix, which is plus, minus, minus, plus in 2 by 2. Okay, that's the shape, okay? So this one gets corrected with a plus sign, so that's plus D. Okay, now let's take B. Let's delete the row and the column that B is in. Okay, we see that we have C, just the determinant of the 1 by 1 matrix, which has C in it. That's just the number C. Now that needs to be sign corrected. Okay, we see that it's first row, second column, which has a minus sign, so that gives me minus B. Okay. Then I have C. Sorry, that should be minus C. Yeah, minus C. Okay. C, then delete the row in the column, I get B. Okay, which is just B. That needs to be sign corrected. It gives me minus B. And D, delete the row in the column, gives me the determinant of A, which is just A. Sign corrected is plus A. Okay, so now the cofactor matrix is what? The cofactor matrix is D minus C minus B and A. Okay, like that. And the adjoint pen's starting to die is what? Well, it's the transpose of that. Okay, so that means I leave the D where it is. Okay, interchange the first row and the first column. So D is in my first row, minus C now goes into my column. I have minus B that was in my first column, now it has to be in my first row, and A stays where it is. Okay, so that's my adjoint matrix. So I have that the inverse of A is equal to 1 over the determinant of A. Okay, and what do I multiply it by? I have a 2 by 2 matrix, which is the adjoint matrix, which is D minus B minus C and A, which is the formula you're all familiar with. So this cofactor expansion on this adjoint matrix is actually where we find the original matrix determinant formula for 2 by 2 matrices that you've already seen before. Okay, so these are all of the same ideas, they're just being used in this context now for the first time. You probably haven't seen them like this before. Okay, so that's my example where I have the basic ideas laid out. Okay, and in the next video we'll actually go and find the inverse of a 3 by 3 matrix. Okay, so see you then.